So the next project that I'm working on is a spacer for my Vertex grinding vise that I reviewed a little while ago. I need a spacer because I want to use it for multiple purposes, one of which is an extension of my Kurt vise to deal with really long, pieces of material that stick off the end of the vise. So I need to raise this up so that the base of the jaws of this vise match the base of the Kurt jaws, which are 2.85 inches. So I'm going to make a spacer that fits just like so on the bottom. It will mount into the curved portions on the sides of this, so it will be a little wider, as you can see here, and I'm going to thread some 1/2 inch 13 holes, and I'm going to make some clamps over here that will fit in here. I'm going to make the radius a little bit smaller so that it will not touch edge to edge, but it'll be very close. And I'm not going to make it quite as thick as this so that I can stick it in and have some adjustment space. So here's the clamp down points. Again, this is the side view. The top view, the Vertex vise will sit here and the clamps will be either side. I didn't put it on the drawing yet because I was still thinking about it, but I think I'm going to slot both sides of the spacer, and the slots will allow me to clamp it down to the table on the mill. So I have two choices of material. I originally went to buy cold roll steel, and I was gung-ho for that until I picked this sucker up. It weighs 40 pounds. I only need about that much of it, but still that's going to be 30, probably around 30 pounds. And with my back, lifting up heavy things is a problem. So I found a piece of aluminum that also fits, and I might go with that. And here's my thinking. I know that aluminum has terrible wear properties, so if I were to use this a lot, that would be a bad choice because it would go out of square, I'd constantly get dings, and that may still be a problem, but I don't think I'm going to have to use this all that often, so if I'm careful with it, I think I'll be okay. So I'm going to make the first one out of aluminum. If I need to make another one later, I've got the drawings and I've got the materials, so I'll just do it. But for the first go around, I'm going to try aluminum and see how that works out. So without any ado, let's just get started and dimension some stock. And here's my dimension stock. So this piece here is the spacer. It's within about 1/1000th, maybe 2. And this will sit on top of it. These two pieces here will be the parts that sit down in the base and screw down, one on each side, and have a radius to match along the outside edge that matches this radius here on the side of the vise. The way I calculated what the radius of circle this would be was I measured the width and then I measured the depth with the depth mic. So now you've got a chord and the depth of the chord, perpendicular depth of the chord from the circle. So you can either use geometry or I cheated. So in my CAD program, I drew a line that was the width of that slot, and then I drew another line that was the depth that I measured with the depth mic, and then told it to plot a circle with those 3 points included, which gave me a circle, and then I found out, I used the measuring portion of it to figure out what the radius was, which is a little over 2 inches. I'm going to do 2 inches even so it won't quite touch on the sides. I like that better. So in order to make this now, I've got a little bit of a problem. So if I were to just mount this on the rotary table, the center of the rotary table being here, and I got this piece not exactly symmetrical about a radius and perpendicular to that radius, what would happen is that the circle I'd be cutting on the edge would not be symmetrical. So I was trying to think of various ways to do that, and I could just try and measure it and line it up. But what I thought would be more interesting would be to make a fixture. So these are actually really inexpensive slugs. If I bought the cutout piece, this would be like 25 bucks, but these are actually thrown away mistakes that they had in my local metal supply place. So I'm going to make a fixture out of this, and I will make it so this is mounted at 4 inches, so that the edge is at 4 inches out from the center, or actually 2 inches out from the center, 4-inch diameter. And I am going to machine a slot into it that's perpendicular to that radius so that this thing stays in the proper orientation. So it will have 2 sides and a bolt through it to keep it oriented, and then I will machine it on the rotary table. So first I've got to put this guy in the lathe and face both sides, put a center in it that has the proper diameter to match my auto centering Morse taper insert on my rotary table so I can skip that step. and we'll go from there. So here's facing the disc. So next I need to drill and bore the center of this to match this diameter very closely. This piece here, this MT2 or 3, I think 2, fits inside the rotary table, and this piece will stick up through here to align this, so that once I have the rotary table aligned on my mill, I don't have to go and align this piece as well. It'll be automatically aligned. So we're going to drill and bore for this. This is approximately an inch. It's actually 2/1000 under. So we will make it very close so it'll be a tight fit. So as usual, we're going to drill and bore this. We're going to start by drilling up larger sizes up to about 3/4 or 7/8, and then do the last bit by boring so we make sure it's straight and smooth. We bore. So I went about 1/1000th over. Well, somewhere between 1/2 thousandth and 1/1000th is a very snug fit. So there you go. Can't really wiggle. Nice fit as long as there's lube. It gets a little tight, so I think there's a little tiny bit of taper on this. So it should be good. Alright. Alright, so this part's done. Now I just need to put a bolt hole pattern in here, countersunk, so that this can be mounted on the plate directly. This will help center it, and we'll be good to go. So I've updated my drawings here to include the fixture that I'm going to use to cut the circular profile in the parts that will hold in the edge of the vise that fit right here. And I was planning on a 7-inch piece of aluminum, but when I went to the industrial metal supply, they had a bunch of pieces, which you saw me face this a little bit, but they're smaller than 7 inches, so I'm going to have to amend my bolt circle diameter to meet the new dimensions here. This is somewhat smaller, but you know, beggars can't be choosers, because the price of this is like 1/3 the price of a cutoff piece, you know, of the actual diameter you want. So this is considered scrap. So I'm going to find the center of this part, go out and drill my 1/2-inch hole, drill and tap the 1/2-inch hole, and then I got to mill out the section that will be for holding the part in to be cut. So I'll bring you right back. So first step is I need to find the center of this and get that under the center of the spindle. So my go-to solution was to grab this copy of the Blake coaxial indicator and line it up. But I recognize that this is not an ultra precision operation. The bolts locations have to be accurate so I can lock into T-slots, but within a few thousandths. And the placement of the part doesn't have to be exact. If this curve is not perfect, you know, I'm off by 1/1000th, it's not going to make a huge deal. So I thought, oh, I've got this MT3, which I thought was an MT2 earlier, but it's a Morse Taper 3 to the center adapter that I use on the rotary table to locate the center. So I thought, oh, perfect. I also have this R8 to Morse Taper 3 adapter. So I am going to use that to line this guy up with my spindle and find my 0 points. And I'll bring you right back. Quick and dirty. Alright, so I found my 0. And this thing was within 1/1000th of the diameter. That fits very nicely. So now we've got our 0 center, and we're good to go. So next we'll drill some bolt holes. So first, now that we found the center, we're going to go over 1.0005 inches, and we're going to drill and tap. And that's just right along the horizontal axis, no Y offset. So let's get that spot. Right, so first we're going to drill a pilot hole. Material's a little over 1 inch thick. Alright. Now for the tap drill size, 27/64. Sorry about the bouncing there. The chart I use has tapping drill size for both hard and soft metals, which is a little unusual. Usually it's just 1 entry. Chamfer and tap. I'm going to slow this down, try and power tap it. I don't know how well that's going to work, but we'll try it. I didn't chamfer it because I'm actually going to mill right through the same area, so it wouldn't have lasted anyways. So next step, we're going to do the bolt holes. Alright, so now I just have to drill the 3 bolt holes and then machine out the spot for the piece to sit in. So I'm almost done with the bolt hole pattern. I decided not to show you all the drilling since that's sort of pedestrian. So here we are with the countersinking bit. And I'm getting depth by this right here, my Michutoyo quill depth gauge. Getting close. There we are. Now all we have left to do is the milling, the square part here that's going to hold the part that'll screw in here and be aligned by the grooves that I'm going to put in here. One thing I would like to say is this countersinking bit for cap screws, it's a Chinese set, and although it cuts all right, I'm not very happy with the sizes, and it's obviously designed for a sloppier fit because I would expect the 3/8 to have a 3/8 pilot with the just over ½ inch countersink part, but this is actually a full 32nd over, and I don't typically like to do my holes that sloppy, so I don't know, maybe there's multiple grades of these, I gotta look it up, but not particularly happy with that aspect of this. So anyways, next step, the milling cutter. Well, I blew it. I work really long hours, so I was not able to finish this part in one day, and I sort of have a personal policy where I don't leave my machines dirty and things set up in the vise when I'm not there unless I'm coming back very shortly. And so I pulled this out of the vise, and now getting the alignment, since I didn't mill the slot in this that's going to help align this piece, this fixture is going to be really hard to get this part aligned along this radial axis again, because if I put it in the vise I could find center very easily, but this angular rotation has to be perpendicular to the jaws of the vise. Now I could do it with a bunch of fiddling, but it would be challenging. Instead, if I use the rotary table to center this and then adjust it radially, the radial angle going around, if I make a part that matches this diameter of the center locator, I can just put a flat along it and then measure along it to get the right angle that will make this centered. So that's what I'm going to do the next part, and if that's a little confusing, I don't know that I explained it that well. If that's a little confusing, hopefully it'll be all clear after I make this part. So I could just, you know, make some stock exactly this diameter of this center locating piece and put some threaded rod in it, but I thought it'd be more fun to just thread it. So that's what I'm going to do. Thus far I've pre-dimensioned the stock here, and this is a little bit over because I'm going to cut that to final dimension when I slide more material out, but I wanted to not leave too much stick out for the threading part. So I'm going to cut the relief right now, and this is dimensioned for the major diameter of the 1/2 inch 13 threads, and this guy is going to go in just past the minor diameter, about another 10 or 15 thousandths to leave some clearance and stopping space for the threading tool. So let's just do it. So next we're going to set up for threading, and we'll be right back. So I've got my angles set here, and next we can set up to do a first pass. So according to this really old table I found online that I printed out, it tells you depth of feet. So at 13 threads per inch. If you come over here, you can't see up here, feed a compound at 30 degrees. I need to go in about 58 thousandths, 0.0577 inches. So that'll tell me how far to drive my compound in for, the thread should be right. So we'll see how well this works out. So we're going to do a 10,000 scratch pass. That goes, and that's right on the money. Alright, so let's do some thread. This is aluminum, so I'm being kind of aggressive at the cuts. Not A-bomb aggressive, but aggressive. I'm doing 10 thousandths depth of cut for the first few. I think we'll do a couple spring passes after this. Not changing anything. Spring pass. I think we'll do another one until it's clear. This is making up for deflection in the tooling and the part itself while it's cutting under the heavier feed rates. Another spring pass. Alright, that looks pretty good. And let's test fit it. Well, before I do that, take off the sharp edges here. Alright. Okey-doke. So, one thread. Oh yeah, that's a good solid fit. No wiggle. That's just dead on. That is perfect for whatever the dimensions of this one are. I should probably find some basic thread gauges if I can find them online cheap. They tend not to go too cheap though. This one is just a little tight. But I think we're going to go with it. Actually it's great. No, it's perfect fit. That's actually the best threads I've ever done. So, at least in my personal opinion. So I'm going to stick with that. I'm going to chamfer this end a little bit down here, and then I'm going to take this to its final dimension. This is the part that needs to be 0.998 thousandths to match the center locating pin. So I'm going to reset up and I'll bring you right back. So let's chamfer this starting thread a little bit. So now we just need to kick this part out a little bit, get it to final dimension. So I'll bring you right back. Alright, so we have about 7 thousandths to take off, but I want to walk it in because I'd like it to be accurate, and I guess I'm going to use a little lube. I don't think it's going to be particularly useful in this case, but let's walk this in. Start with 5 thousandths. So let's see where we're at. .002, a tiny bit of taper there. So we need to come down 4 thousandths. Let's just do another 2 thousandths. throw some chips. So it needs 1/1000th to come off. Can we even do that? Good question. So it looks like I can only do this in like maybe 3/10 increments because that shifted by another couple tenths. So we should be able to like 0.997 like 8 or something like that. 0.9, oh, actually the DRO is off a bit. Wow, look at that, right on. I'm only like 1/10 off. Okay, we're gonna call that a win and then some. Okay, so next stop, just part this guy off. So I'm ready to part. I'm leaving the nut on here in case I drop it so I don't damage the threads, because it is just aluminum, so very delicate. The actual depth here doesn't really matter. So we're just going to take it off here. This part is not a critical height part. It just needs something for a flat surface to go against, so that's it. Now let's slow that down a little bit. There we go. Getting close. There it is. Okay. So here's the part. I'm just going to put it back in, reverse it, and chamfer that edge a little bit, and we'll be good to go. So here's the threaded part. Here's the alignment. It's a a 3MT alignment pin for the rotary table to help find center, but I can also use it to find center on the mill, because I've got the MT to R8 adapters. But in any case, so this is the one I just made, and now I can put flat across here, or just search for the peak, and I can make sure that this orientation is correct, because I can make sure that I'm perfectly aligned the horizontal orientation. So we'll come back to this later. First I have to do some work on the hold down clamps next, because if I get the order of operations wrong again, I'm going to be doing a lot more in and out of the fixtures, so I'm trying to think ahead a little more this time. So the next step we're going to do here is for the curve, it's undercut so that it can pull down on the vise. So we're going to undercut this, we're going to do this undercut for the ledge here. So before we do the round part, that way we'll take off less material too. So let's go over to the setup. So we're going to be cutting along the back. I'm going to use a roughing mill, a roughing finishing end mill for the first few passes until I get down to my final depth. And then I'm going to come back with an end mill just to finish it and make it nice and clean. So let's try a 2/10 of an inch depth of cut and a fairly slow feed rate. We're doing both parts at once to make this a little more efficient. Nope, lifted the part, damn it. I do not have a great bite on this, so let's see if we can fix this. So one of my mistakes here is I did not machine both these parts side by side. So they're probably, 1/1000th or two different from each other, which means the clamping pressure is not equal. I think I'm running into that. So let's try a 100,000th depth of cut. Let's see if that does some lifting. Alright, let's try the other way. Let's go back to 200 thousandths where we started. And come back the other way. So this will be another 100 thousandths depth to cut. This will mean I'll have to do 8 passes. Part of my problem is here I don't have a really big bite on these parts either, only 1/4 inch. So it's a perfect storm of bad choices or bad situations. I'm going to do some finishing passes, take off the last few thousandths with this 8 flute or 7 flute end mill. Let's see which one. It's a helical 7 flute. So I can't easily get a good angle, and the chips mostly go back, so I don't want the camera back there, so I'll bring you back when it's done. This is really isn't a good angle for this. So here's the first step done. I don't know how well you can see that, but there's the first ledge, so the round part will be here. And now I've got to cut slots in both sides, and we'll do those both simultaneously again, like I should have done the whole roughing from the beginning. Bring you back. So here's my quick solution to locate the rotary table without using the center finder. So we'll start with my 1-inch collet, and that is on this 0.998 adapter I made for the M3 tapered to threaded alignment pin. And now I've got the rotary table loose, not attached. Right there you can see it's loose. Come up here and make this my 0 point for X and Y. Come down here, lower my quill, using that to center, and I'm going to lock this off right there, and then I will tighten the nuts holding the plate down carefully, and when I am done, I will be centered. I now have my 0 point. Next, I will use the alignment pin to center my fixture and tighten it down. So now what I'm going to do is I am going to drop the collet back down to pull this. So another couple observations. One is you need to torque these 3 screws evenly. I redid it because I wanted to add a spacer, because I'm actually going to, once I find the perpendicular, I'm actually going to put a flat on this thing on both sides so that I can find it in the vise again. That way I'll have something perpendicular to this row right here, this axis. Anyways, so when I redid it, it got kind of stuck, so I had to use the Allen screws here, drop down in here to pick this guy up out of here. Yes, it gets really tight very quickly. I mean, everything's so close in tolerance that a few thousandths you've wedged it, and it's surprising how well it holds. Anyways, so that's a bit of my opinion there, and next let's see if we can find the center. Alright, so I know this is kind of tight in here, so what I've done is I've got myself at my 0 point here using the DRO. Alright, there's the 0 point. Now I'm going to set my 0 on my y-axis, and then I'm going to move over until I'm by the other block. And you can see that moved about 30 thousandths. So now I'm just going to rotate the rotary table until that's 0, and all things being equal, it should be really close. And there we are. So didn't quite come back to 0 here, but there is a little slop in the ways. There you go. Yeah, every time you reverse directions, there's a little bit of slop in the gibs. But we're within 1,000th. I'll buy that since this isn't ultra critical. So now what I'm going to do is I am going to, now I'm going to remove the pin, the unthread this one, remove that one physically, and then I'm going to mill some flats on the north and south side of this guy so that I could pinch it in the vise, and that would put this guy at 90 degrees. So that's what I'm going to do first, and then I'm going to machine the slot that I was intending to do all along. Let me lock the table. So we're just going to mill a flat, and actually we only need one, but I'm probably going to do two, and they don't have to be very significant for the vise to grab them. So let's take this out of back here where I had it left, where I left it. And spin her up. And we're just going to touch off. I need to make sure that below the part, there we go. All right, there we go. So let's go in, we'll make this 3 even. That's where we're gonna go. All right, so now we're just gonna mill the slot. It's kind of got terrible flexions, sorry about that. So now we're just going to mill the slot, and we're going to go in a quarter, and we're going to go off this axis plus or minus 0.6775 on the y-axis. So let's see if we can take a 1/4 inch bite one time. See how that works. Let's see if we can use power feed. Alright, so here's the pocket that will hold this guy. You'll notice there is almost no play whatsoever. And it will be taking a screw, 1/2 inch bolt, like so. I think I'm going to add a washer to it. But I'm going to come back, I'm going to swap out this cutter for a steel cutter, and I'm just going to do the radius as long as it's here. Alright, so here we are on the rotary table. I'm going to fire it up. We got to come way out because the edges are going to touch first. So let's just see where we hit, and we can come in a little. Alright. So there was a little. And a little. Come in a few more. And keep going. We're ultimately doing a 2-inch radius, but I got to take into account the width of the cutter, which is 1/2 inch, which makes it 2.250 on my DRO. First, I couldn't figure out what was going on. I forgot, oh yeah, cutter is not infinitely thin. It's not a point or a line. Each time you can see the curve goes a little bit farther in. Let's see if we can get you in closer here. Shooting little needles at me. Very comfortable. Probably should have put up a shield. They're amazingly sharp. And just to test, I'm going to come back the other way just to clean up. see it catches just a little bit of material. So the fixture works extremely well. If you were going to do a lot of these, I definitely recommend steel for the fixture, because at the end of all this, it's really hard to get this guy out of here. I have to tap it with a hammer because it's twisted ever so slightly, and I think it just gouges into the aluminum a little bit, even though it's still fairly tight. At least the last one was. So that's it. I'll take it out and I'll bring you back. Home stretch. We got the clamps done, which was the complicated part that required a fixture, or at least I wanted to make a fixture for it. We just have to do milling of slots in the sides of this guy, and a slot and a tapped and two tapped holes for the clamps on either side. Right now I don't have an easy way to shoot the milling. The vibration on the previous shots was really unacceptable to watch, so I got to make a new bracket for the milling machine. So I'm just going to skip by this and I'll bring you back when I'm done. Okay, so here's the finished base, and I milled out both sides, put tapped and threaded for 1/2 inch 13, also put slots on each side for holding down to the mill. And assembly pretty much just goes like this. You just pick the vise up, carefully set it on here. This is where, if it gets used a ton, I am going to have to make the base out of steel, because you know, it will wear with aluminum. Aluminum is not particularly wear resistant, as I mentioned before. Pop a couple screws in, bolts. And then to get it lined up square with the base, since there is a little bit of latitude, if you put this on a flat surface before you snug it down, this is not a perfectly flat surface, but this is just an example, then you're good to go. Now the vise is the base of the vise, the bottom of the jaw is this vise, match the Kurt vise. So let's go over the mill and take a look at how you can use it. So now if I have a long piece of stock, like this large parallel here, and I'm actually working on, I can support it with the vise. Now the spacer brings the bottom of the Vertex jaws to the bottom of the Kurt jaws. Thank you very much. Appreciate you watching. Hope to see you next time.